Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set 5 of 5 good problems on the chapter of polygons where I will solve relatively 5 harder problems on the chapters of polygons, quadrilaterals and parallelograms. I have already completed 20 hot problem on the chapter of polygons in the previous 4 sets. If you have not watched those videos, I strongly suggest and request that you please watch those videos as well. So this video is part of the playlist Maths 8 Hot. HOT Hot stands for High Order Thinking, where I solve relatively harder problems from every chapter as and when they are completed in the other playlist, that is CBSE Maths 8 or S. Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the set 5 of 5 good problems on the concepts of polygons, quadrilaterals and parallelograms. Okay, so I have the five good problems on the left hand side. I hope the fonts of you can see the problems on the left hand side clearly, and the fonts are big enough so that it can be read properly. On the right hand side, I will solve the problems. The link to the PDF of the 5 good problems of set 5 will be there in the description below. As you can see in the there is a mistake in the PDF. It is saying set 1, but it is actually set 5. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution. And as always, try to solve the problems yourself first. Only when you are stuck, or if you want to see my solution method, then please watch these videos. Watch this video. And also notice that there is not a single method of solving a mathematical problem. There could be multiple ways of solving a problem. I will use my way of solving a problem based on my understanding. And also at the end of the after solving all the problems, I will discuss about the key concepts and formulas that was used to solve the problems, which is very, very important for you to also revise the key concepts to solve the problems. Okay, so let's start solving the problems. The first problem says that ABCD is a parallelogram. The angle bisectors of ABCD form a quadrilateral EFGH inside ABCD. Then EFGH is a rhombus, rectangle, square or parallelogram. Okay. How do we know that what kind of quadrilateral is EFGH that is formed inside the parallelogram? One way is that since the quadrilateral inside EFGH is formed by angle bisectors, we can possibly use the angles of the parallelogram. Now, so we know that let's say so in parallelogram ABCD, we know that every pair of adjacent angles are supplementary, that is their sum is equal to 180 degree. So we must have angle A plus angle B equal to 180 degree. Okay, now I am trying to find what can possibly this angle be, that is angle G from the triangle AGB. Now, so in triangle AGB, from the angle sum property, we know that in a triangle the sum of the 3 angles is equal to 180 degree. So we must have GAB plus GBA plus angle AGB is equal to 180 degree. Okay, now this implies, what is angle AGAB? This is angle GAB. This is nothing but since AG is the angle bisector of angle A, this will be angle half of angle A. Similarly, what is angle GBA? This angle will be half of angle B. Half of angle B. We have plus angle AGB equal to 180 degree. So this implies half of angle A plus angle B plus angle AGB is equal to 180 degree. This implies angle A plus angle B is 180 degree. So we have half multiplied by 180 degree plus angle AGB is equal to 180 degree. Clearly this implies that angle AGB is equal to 180 degree minus 90 degree, which is equal to 90 degree. So we see that in in the quadrilateral EFGH, angle G is equal to 90 degree. Similarly, we can find, using the same concept, we will see that angle E is also will be 90 degree. So let's see. So we have angle D plus angle C will be equal to 180 degree, as they are adjacent pair of angles in the parallelogram ABCD. Okay. Now in triangle DEC, we have angle EDC plus angle ECD plus angle DEC should be equal to 180 degree using the angle sum property of a triangle. So this implies, what is angle EDC? Angle EDC, this angle is half of angle D, since DE is the bisector of angle D. So half of angle D. Similarly, what is angle ECD? This angle is half of angle C, since EC is the bisector of angle C. So we have this equal to 180 degree. So this implies half of angle D plus angle C plus angle DEC is equal to 180 degree. This will imply half angle D plus angle C is 180 degree plus angle DEC is equal to 180 degree. This will clearly, from here we clearly get that angle DEC is also equal to 90 degree. So what is angle DEC? Angle DEC is this angle, that is angle E of the quadrilateral EFGH. So this implies in EFGH, angle E is also equal to 90 degree. So we have found that angle G and E in the quadrilateral EFGH are both 90 degree. Similarly, we have to we will see that angle H and F will also be 90 degree. So we are basically using the fact that using the fact that the inside quadrilateral EFGH is formed by by the angle bisectors of the parallelogram. Now okay, so I have another reference diagram. Okay, now again, in triangle AHD, in triangle AHD, we will have angle HAD plus angle HDA plus angle AHD is equal to 180 degree. This implies, what is angle HAD? This angle HAD is nothing but half of angle A. And what is angle HDA? This angle is half of angle D. And we have angle AHD is equal to 180 degree. This implies half of angle A plus angle D plus angle AHD is equal to 180 degree. This implies half of angle A plus angle D similarly will be a supplementary, as they are adjacent pair of angles of the parallelogram ABCD. So we have this A equal to 180 degree. Clearly from here we will see that angle AHD will also be equal to 90 degree. So this implies, now what is angle AHD? AHD, this angle, is equal to, also we can see is vertically opposite to this angle. So this is equal to angle H of the quadrilateral EFGH. So angle H is also 90 degree. Now clearly the remaining angle F of the quadrilateral EFGH has to be 90 degree. In EFGH, if three angles of a quadrilateral are all 90 degrees, then definitely the fourth angle has to be 90 degree, because in a quadrilateral the sum of all the angles is equal to 360 degree. So we know that we must have angle H plus angle E plus angle F plus angle G is equal to 360 degree, and we know that already angle H is 90 degree, angle E we have already found to be 90 degree, angle F we don't know yet, and angle G we have already found to be 90 degree. This is equal to 360 degree. Clearly we can see that from here angle F will be equal to 90 degree. So we see that so clearly, so in the quadrilateral EFGH all the angles are equal. So in EFGH, that is the quadrilateral EFGH, all angles are 90 degree. Now this will imply, what can the quadrilateral EFGH be? It can either be a square or a rectangle, because we know in the given choices only this rectangle and square, all the angles are equal to 90 degree. This implies EFGH is a rectangle or a square. Now we have to decide between whether rectangle and square regarding the structure of the quadrilateral EFGH. Now in a square we know that all the sides are equal. Will this figure or problem guarantee that in the quadrilateral EFGH all the sides are equal? It is not. It is not, because no information is given about the sides of the parallelogram. So we cannot say anything, we cannot have any results regarding the sides of the quadrilateral EFGH. Now I cannot prove that the quadrilateral EFGH is not a square, but I can give a counter example by drawing a figure where the quadrilateral EFGH will be a rectangle. It will not be a square. It will be a rectangle formed by the angle bisectors of a parallelogram. So let's say there is a rectangle. I'm drawing a rectangle. Now this figure will not be definitely perfect, but I am trying my best. So let's say this is a rectangle that is formed inside a parallelogram. So this is a rectangle. This is definitely not a square. I am trying to show that even a rectangle can be formed by the angle bisectors of a parallelogram. If it is so, then definitely we cannot in this problem say that the EFGH will be a square. No, it has to be a rectangle. So let's say this. Now how this rectangle can be formed from angle bisectors of a parallelogram? So I'm extending this. So this has, so let's say this was H, E, and F, and let's say this is G. So I am extending EF as the angle bisector of angle C of the parallelogram ABCD. So let's say this is, I'm extending it. I will then let's first draw all the angle bisectors. Then I will form the parallelogram. So I have this. Similarly, the side GF will be formed by some angle bisectors of the angle B of the parallelogram. It will be like this. Similarly, the side HE is formed by the angle bisector of angle D of the parallelogram, and finally the side HG will be formed by the angle bisector of the angle A of the parallelogram ABCD. Now I need to form the parallelogram ABCD. Now how can I form? Clearly the point A of the parallelogram ABCD will lie on the extended HG. The point B will lie on the point vertex B of the parallelogram will lie on the extended side of GF. So let's say I can easily now, let's say if this is A, let's say this is A, and let's say this is B. So let me join here the side AB. Sorry, this is, I am drawing very approximate figure. So this is AB. Now I have to form its opposite sides DC parallel to AB and equal to AB. So let's okay. So can I copy this one, create a duplicate? Let me see. No. Okay, I will try manually. Okay, so now I can clearly see that, let's say this be the point, D. So approximately I can have the point C somewhere here, and let me join DC, and we will have the parallelogram ABCD. Even though it is not really looking like the parallelogram ABCD, BC is not really looking parallel to AD, but you can, if AB is equal to DC, then it would be more accurate. Anyway, I just showed you that a parallelogram in general can also, if the angle bisectors of a parallelogram ABCD can also form a rectangle inside. So this problem does not guarantee that the inside quadrilateral EFGH will be a square. It has to be a square or a rectangle, but for a parallelogram in general, where no information is given about its sides, then the inside quadrilateral EFGH has to be a rectangle. So the correct choice is B. So rectangle. Okay, let's do problem number 2. Problem number 2 says, okay, you can take a screenshot. Okay, problem number 2. ABCD is a quadrilateral inscribed in a circle. Inscribed means a quadrilateral that is drawn, a quadrilateral whose all the vertices are on the circumference of a circle. So in this, as you can see, the quadrilateral ABCD, all the vertices ABCD are on the circumference of the circle. So ABCD is a quadrilateral inscribed in a circle. This type of quadrilateral is also known as cyclic quadrilateral. Okay, so ABCD is a cyclic quadrilateral. Okay, so ABCD is a quadrilateral inscribed in a circle where it is given BC is equal to DC. BC is equal to DC. So we have BC is equal to DC, and angle DBC is 25 degree, and angle BAD is x degree. Then find the value of x. Basically, we have to find the angle x degree. Okay, so in triangle BCD, we have BC. It's an isosceles triangle. Since two sides are equal, BC is equal to CD. This will imply that the opposite angles will be equal. That is, angle CBD will be equal to angle DBC, which is given to be 25 degree. Okay. Now, this implies that using the angle sum property, we can in triangle BCD we can easily find the angle C. So this will imply in triangle BCD, angle BCD will be equal to 180 degree minus angle CBD plus angle CDB. CBD and CBD. Okay. Now this is equal to 180 degree. Both the angles CBD and CDB are each 25 degree. So 25 degree plus 25 degree. This is equal to 180 degree minus 50 degree. That is 130 degree. So angle C of the triangle BCD is 130 degree. Now, or we can say that in ABCD we got angle C is equal to 130 degree. Now, one concept you must know very well, that if a quadrilateral is cyclic, that is, if all its vertices are lying on a circle, then the opposite angles will be supplementary. ABCD is a cyclic quadrilateral, implies that angle A, that is the opposite angles A and C, is equal to 180 degree, and also we will have angle B plus angle D is equal to 180 degree. This is a very important concept. In a cyclic quadrilateral, the opposite angles are supplementary. Now this will imply, now what is angle A? Angle A is x degree, and what is angle C? Angle C is 130 degree. So 130 degree has to be equal to 180 degree. So this implies x degree is equal to 50 degree. If we ignore the degree, we get x is equal to 50. So the value of x is 50, and hence the correct choice is C. C is the correct choice. Okay, let's do problem number 3. Let A be the exterior angle of n-1 sided regular polygon, and B be the exterior angle of n+2 sided regular polygon. If A minus B is 6 degree, then n is, we have to find the value of n. So what is A given? A is equal to the exterior angle of n-1 sided regular polygon. So we know that in a regular polygon of n side, each of the exterior angle is equal to 360 by n degree. So for n minus 1 sided regular polygon, we will have each exterior angle equal to 360 divided by n minus 1 this much degree. Similarly, it is given that B is the exterior angle of n plus 2 sided regular polygon. So we must have B equals to 360 divided by n plus 2 this much degree. Now also it is given that A minus B is 6 degree. So this implies that A minus B is equal to 6 degree, implies that what is A? 360 by n minus 1 this much degree minus 360 divided by n plus 2 this much degree is equal to 6 degree. Now we can ignore the degree from both the sides and we will get 360 divided by n minus 1 minus 360 divided by n plus 2 is equal to 6. Now let's take from the left hand side, let's take 360 common as a factor and we will have 1 by n minus 1 minus 1 by n plus 2 equals to 6. So this implies we can cancel out, we can divide both sides by 6 and we will get 60 multiplied by now first let's simplify this part. So this is equal to 360 multiplied by, I hope you are aware, you know how to do addition and subtraction of rational numbers where the rational numbers have variables. For example, 1 by x plus 1 by y is equal to x is equal to y plus x divided by xy. Or let's say p by q minus r by s. This is equal to ps minus rq divided by qs. So I hope these concepts are known to you. So we will have over here n plus 2 minus n minus 1 divided by n minus 1 multiplied by n plus 2. This is equal to 6. Okay. So this implies if we simplify the left hand side, we will get the numerator is n plus 2 minus n minus 1. It will be 3 and in the denominator we have n minus 1 multiplied by n plus 2 is equal to 6. So this implies that if we do cross multiplication, we will have 6 into n minus 1 multiplied by n plus 2 is equal to 3 into 360. So this implies dividing both sides by 6, we have n minus 1 multiplied by n plus 2 is equal to 3 multiplied by 360 divided by 6. This is 180. This is 180. So we have this equation or relation that n minus 1 multiplied by n plus 2 is equal to 180, and we now have to, from this equation we have to find n. How do we solve? How do we find the value of n from this kind of equation? So the concept is that notice that n minus 2 and n plus 2, now n is definitely it is a natural number, and n is also since it is a side of a regular polygon, n is greater than equals to n is greater than equal to 3. We know that in a polygon the minimum number of side is 3, so n has to be greater than equal to 3, and it's a natural number. So what will be the value of n such so that it is greater than equal to 3 and it is a natural number, so that n minus 1 multiplied by n plus 2 is 180. The concept is that to find n, we have to factorize 180 into two factors such that as you can see that n plus 2 is 3 more than n minus 1. So we have to factorize a 180 into product of two natural numbers, so that one natural number is 3 more than the other natural number. Then we can easily find n. So let's factorize what is 180. So 180 is 18 multiplied by 10. So definitely we see that 18 is not 3 more than 10, so it will not work. We have to further factorize this. So 18 is 9 into 2, and let's say we have 10. Now if you take another factor 9 and 20, it will not work, because 20 is not 3 more than 9. So we have to further break it down. So let's say 3 into, let's break it down to all the prime factors of 180. So 3 is 3 into 9, 3 into 3, 2 is 2, and 10 is 2 into 5. So this is the prime factorization of 180. Now from these prime factors we have to create two factors, so that those two factors, the difference of those two factors is 3, because we see that n minus 1 and n plus 2, the difference between n plus 2 and n minus 1 is 3. So now you have to do some observation, you have to use your common sense and basic mathematics and create those two factors. Now I can see that it will be 6, 12. I think it will be 12 multiplied, if I take one factor as this, 3 into 2 into 2, one factor, that is 12, and the remaining is 15. So 15 is clearly, as you can see, this is 12 into this is what is 12? 12 is you can say now, okay, so this is 12 into 15, and we clearly see that 15 is 3 more than 12. So this will definitely imply that n minus 1 has to be equal to 12. N minus 1 is 12. So this will imply that n is equal to 12 plus 1 is equal to 13. So n is 13. Okay, so the correct choice is B. B is the correct choice. So the tricky part was in this problem was to how to solve n, where we have the relation n minus 1 into n plus 2 equals to 180. So the concept is that you have to factorize the right hand side RHS number, in this case 180, into two factors such that the difference of these two factors is 3, because we know that n minus 1 and n plus 2 on the left hand side, their difference is 3, and from there so we can see that the two factors are 12 into 15, and 15 is 3 more than 12. So if I compare now the LHS, that is n minus 1 multiplied by n plus 2, and the right hand side it is 12 into 15, I can clearly say that n minus 1 has to be equal to 12. From here I will get n equals to 12 plus 1 equals to 13. Okay, let's do the next problem. In a quadrilateral ABCD, angle B is 90 degree, and it is given AD square is equal to AB square plus BC square plus CD square. Then value of angle ACD. So I have roughly drawn the quadrilateral ABCD where angle B is 90 degree. So this is 90 degree. Now the other relation regarding the sides, we have AD square, we have AB square, BC square, and CD square. Okay, so we have okay, now Since angle B is 90 degree, I think we must and is AB square and BC square are involved, it is better we make the diagonal AC. So when we connect the diagonal AC, we have triangle ABC is right angled at B. That is B is equal to 90 degree. This implies applying Pythagoras theorem, we can say that AC square, which is the hypotenuse, AC square will be equal to AB square plus BC square. AC square plus BC square, that is applying Pythagoras theorem. That is the square of hypotenuse is equal to the sum of squares of the arms in a right angle triangle. So we have this. Now it is given that AD square is equal to AB square plus BC square plus CD square. Now AB square plus BC square we know is equal to AC square. So we have AD square is equal to AC square plus CD square. So these AD, AC and CD are all sides of the triangle ADC. So in triangle ADC we have AD square is equal to AC square plus CD square. Clearly we can see that if in any triangle we have this so the converse of the Pythagoras theorem is also true. That is, if in any triangle ADC, for in this problem it is ADC, triangle ADC, if you have AD square is equal to AC square plus CD square, then definitely the triangle ADC has to be right angled. Now which angle will be right angled? So since AD has to be the hypotenuse, AB is hypotenuse in triangle ADC, and which will be the angle, right angle in triangle ADC. It will be on the right hand side. You see AD square is equal to AC square plus CD square. Which vertex is common in AC square and CD square? It is C. So angle C is right angle. That is 90 degree. So this will imply that angle ACD is equal to 90 degree. This is what the problem is asking. It has asked to find the value of angle ACD. So the correct choice is A. So this concept you must know that in any triangle, if you know that the square of one side is equal to the sum of the square of other sides, then clearly it will be a right angle triangle, and you can clearly find which angle of the triangle is right angle. In this example, it was in triangle ADC. We see that it is AD square is equal to AC square plus CD square. So definitely AD has to be the hypotenuse. AD has to be the hypotenuse, and the other and you can see the right hand side we have AC square plus CD square. In AC square plus CD square, the common vertex is C. So C has to be the right angle. And the other way of knowing which angle in triangle ADC will be right angle is the angle opposite to the hypotenuse. The angle, this is the hypotenuse AD, and the angle opposite to the side AD is this angle C. So angle C in triangle ADC is the right angle. So we have angle ACD is equal to 90 degree. Okay, let's do the next problem, question number 5. It is the problem says that PQRS is a square and STR is an equilateral triangle. Find the value of M. Okay, so I have roughly drawn the figure. PQRS is a square and STR is an equilateral triangle. Okay, and it is asking to find the value of M. Now, what is angle M? So the diagonal SQ is intersecting the TR of the TR side of the triangle STR at N. So we have to find the value of M, that is angle angle S in R is equal to M degree. We have to find the value of M. Okay. Now, since this is a square, we know that a diagonal, okay, first of all, triangle STR is equilateral. This implies all its angles are equal to 60 degrees. So we must have angle TSR is equal to TSR will be equal to 60 degree. Also 60 degree. Also we will have angle STR is also will be equal to 60 degree. Okay. Now, one concept you must know that all the diagonals of a square bisect all the angles. So SQ is a diagonal. SQ is a diagonal of the square PQRS. This will imply SQ bisect the angle S. So this will imply that this angle, that is angle NSR, will be equal to half of angle S. Now, what is half of angle S? Now, we know that in a square all the angles are 90 degree. So this is equal to half of 90 degree, which is equal to 45 degree. So this angle NSR is 45 degree. Also see that angle TSR, now we have been asked to find the angle M. Now angle M is an exterior angle to the two opposite interior angles, this angle and this angle. Okay, so we have to from there that and we know that an exterior angle in a triangle, an exterior angle is equal to the sum of its two opposite interior angle. This concept we have to apply to find M. So we know that angle TSR is nothing but is equal to angle TSN, the smaller part, and NSR. Okay. So this implies, what is angle TRS? Angle TRS, no, not angle TRS, angle TSR. Sorry, this is angle TSR. In the triangle TSR, the angle TSR is equal to angle TSN. This angle TSN plus angle NSR. So this implies, what is angle TSR? TSR is 60 degree. 60 degree is equal to angle TSN. We are trying to find the smaller angle, this angle TSN plus angle NSR. Angle NSR is 45 degree. So this will imply that angle TNS is equal to 60 degree minus 45 degree, that is 15 degree. 15 degree. Okay. Now we can say that m degree in triangle TSN, in triangle TSN, we can say that angle SNR, again SNR is exterior to opposite interior angles TSN wait a second, I think I have done wrong. Angle TSR is equal to angle TSN plus angle NSR. So this implies angle 60 degrees is equal to angle this is not TNS but TSN. So we have angle TSN. This is angle TSN. We see that in triangle TSN, angle SNR, that is the angle m degree, is exterior to opposite interior angles TSN and angle STR. So this will imply that angle SNR should be equal to angle TSN plus angle STR. So this implies angle SNR is the m degree. So we have m degree is equal to, what is angle TSN? Angle TSN is 15 degree. And what is angle STR? Angle STR is 60 degree. 60 degree. So this is equal to 75 degree. This implies, if we ignore the degree, we have m is equal to 75. M is equal to 75. So the correct choice is D. The correct choice is D. Okay, now as I always say that whenever you are solving a set of problems from any exercise textbook, or any you are giving some test, or in you're solving some problems in from some reference books, or any competitive examination, always as much as possible, always try to recall or revise the concepts that was applied, the critical concepts that was applied to solve the problems. So I will now discuss about the key concepts and formulas that were applied to solve this problem. So this is very, very important. So key concepts used to solve the problems. The first one is that the first concept is related to the first problem. So we know that all adjacent pairs of angles in a parallelogram are supplementary. So this is a very common property of a parallelogram. You must be very familiar with this. So if we have a parallelogram ABCD, so we must have angle A plus angle B is equal to 180 degree. Also we will have angle B plus angle C is equal to 180 degree. Also we have angle D plus angle C is equal to 180 degree, and finally we have angle A plus angle D is equal to 180 degree. So this concept was applied to solve the problem number 1. Okay, the next concept is that in a rectangle and a square, we know all the angles are equal to 90 degree, but in a square all the sides are equal, but in a rectangle it is not necessarily the case that all the sides will be equal. Since a rectangle and a square are both parallelogram, obviously the opposite sides will be equal. The pair of opposite sides will be equal, but in a rectangle the adjacent sides are not equal, whereas in a square the adjacent sides are equal. That is, all the sides in a square are equal. So this concept was applied to differentiate between a rectangle and a square, and to identify in problem So this concept was also applied in solving problem number 1 to identify whether the inner quadrilateral EFGH is a rectangle or a square. Okay. So concept 3 is that this is a very important concept. You must know that if a quadrilateral is cyclic, that is all the vertices of a quadrilateral lie on the circumference of a circle, then the opposite sides, opposite angles of that quadrilateral are supplementary. So as you can see, PQRS is a cyclic quadrilateral. Sometimes it is given that PQRS is a cyclic quadrilateral, or it is same as saying a quadrilateral is inscribed in a circle. A quadrilateral inscribed in a circle also means that the quadrilateral is cyclic. So in this case, in this example diagram, we must have angle P plus angle R is equal to 180 degree, and also we must have angle Q plus angle S is equal to 180 degree. So this concept was applied in solving the problem number 2. Okay. Concept 4 is this concept was applied to solve question number 3. So if you how to find a unique value of n where n is a natural number such that I have considered 3 examples A, B, C. If you are given n minus 1 into n is equal to k, where k is a natural number, how do you find the n? N will be a unique natural number. How do you find n? So the concept is that the left hand side, as you can see, n minus 1 and n, these are two natural numbers. These are two consecutive natural numbers, where n is definitely the successor of n minus 1, or n is basically 1 more than n minus 1. So the concept is to factorize the k into two factors, k1 and k2, where k2 is 1 more than k1. So we have k2 is equal to k plus 1. So if you can find k1 and k2 as factors of k such that k2 is 1 more than k1, then obviously it will mean that k1 will mean that k2 will be equal to n. K2 will be equal to n. Also you can say that n minus 1 will be equal to k1. This will also mean that n is equal to k1 plus 1. So n you can find as so n will be either k plus 1 or n will also be equal to k2. So from k1 and k2 you can then easily find what is the value of n depending on the LHS. The another example B is that if it is given n minus 1 multiplied by n plus 2 is equal to k, where k is a natural number, how do you find n? So the left hand side we can see that n minus 1 and n plus 2 they are two natural numbers whose difference is 3. So n plus 2 is 3 more than n minus 1. So we have to factorize k in such a way in two factors k1 and k2 such that, let's say, k2 is more than k1 by 3, or k2 is equal to k1 plus 3. Then we can say that k2 will be n plus 2. K2 will be n plus 2, or n will be k2 minus 2. Also you can say that, I can say that k1 will be equal to n minus 1. So this will imply n is equal to k1 plus 1. So n you can find either from k1 as k1 plus 1, or you can find n from k2 as k2 minus 2. Okay. So third example is that C, if you have n minus 2 multiplied by n plus 3, n plus 1 is equal to k, where k is a natural number, how do you find the value of n? Now you have to factorize k as 3 factors. As you can see in the left hand side, there are 3 factors. First factor is n minus 2, second is n, and the third one is n plus 1. Now clearly n is 2 more than n minus 2, and n plus 1 is 1 more than n. So if you factorize k as k1, k2, k3, then k2 must be 2 more than k1. So that is k2 will be equal to k1 plus 2. K3 will be 1 more than k2, that is k3 will be k2 plus 1. if you can find these k1, k2 and k3, then definitely we will have n minus 2 will be equal to k1 and k2 will be equal to n and n plus 1 will be equal to k3. So from n minus 2 equals to k1, you can easily find n as n will be equal to k1 plus 2. Also n will be equal to k2 and also n will be equal to k3 minus 1. So this way you solve for n where this kind of relation is given. So this concept was used to solve the problem number 3. The next concept is the Pythagoras theorem. You know that in a right angle triangle, the square of hypotenuse is equal to the sum of the squares of the arms. But the reverse is also true. If in a triangle, let's say in the example A, in the triangle ABC, it is given that BC square is equal to AB square plus AC square. So from here we can clearly say that BC must be the hypotenuse of the triangle ABC and the other two sides are the arms. Now what will be the right angle? What will be the right angle of the triangle ABC? It is the angle opposite to the hypotenuse, that is BC, which is A. So how do you find the angle which is right angle in a right angle triangle? It is the angle opposite to the hypotenuse or the common vertex of the two arms. So in this triangle ABC, the arms are AB and AC and they have the common vertex as A. So A must be the right angled. A must be 90 degree. So in this case, this is 90 degree. In the second example B, it is given that in triangle PQR, PR square is equal to PQ square plus QR square. So clearly PR is the, so in the first example BC was the hypotenuse. In the second example PR is the hypotenuse. So definitely the angle opposite to the side PR, Q, this must be 90 degree. 90 degree. So this concept was used to solve the problem number 4. Problem number 4. Okay. The last concept is that in a square, the diagonals bisect all the angles. So this concept was used to solve the problem number 5. So we know that in a square, the diagonals bisect all the angles, and we also know that in a square, all the angles are 90 degree. So definitely this angle will be 45 degree. This angle will be, there is no space. So let's say if these angles are all, these angles all will be all same and they are equal to 45 degree. All this angle will be 45 degree. So this is a concept you must know for a square. Also as a side note, only in a square and rhombus the diagonals bisect the angles. But in a square, since we know that each angle of the square is 90 degree, so we can say that all the bisecting angles, that is all the diagonals will bisect the angles into two angles which is 45 degree each. But for a rhombus we cannot say, since we do not know what will be the angles of a rhombus, it can be anything. We cannot say what will be what are the each bisecting angles produced by the diagonals. So with this this brings to an end in solving the 5 good problems of set number 5 on the concepts of polygons, quadrilaterals and parallelograms. I will possibly make more videos, I will solve for more 5 good problems on these chapters, that is polygons, quadrilaterals and parallelograms, in future sets. So please keep an eye on this playlist, that is Maths 8 Hot. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the other playlist, that is CBSE Maths 8 RS Agarwal, I will soon start the next chapter, which I guess is area and perimeter of parallelogram and trapezoid. I'm not sure. So also stay tuned for that video coming soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.